What's up, everybody? This is Matt Brown with another IoT hacking video. Today we're going to take our second look at a Netgear AC1750 Wi-Fi router, the NightHawk series. And in this video, we're going to build upon our place that we left off in our last video. If you remember in our last video, we found a unauthenticated UART shell from the hardware of this device that gives us a full root shell on the underlying Linux system of this Wi-Fi router. So now, in this video today, what we're going to do is we're going to take that UART shell and extract all of the firmware. And we're actually going to show two different ways, the two main ways that I will use a root shell like that to extract firmware off. In a lot of other videos, I would demonstrate what I call kind of the nuclear method of extracting firmware, where you have to pull the chip off of the board, you have to desolder it from the PCB and place that chip in some specialized flash reader and extract the flash contents out that way. Well, we don't have to do that in this case because we have a root shell on this router, and we're going to utilize that today, and I'm going to show you the two methods that I use predominantly to perform those actions. So I'm going to go look at the desk really quick, and then we're going to jump back to the computer. So the only thing that I've done from last time is I have plugged in the Ethernet WAN port of the Wi-Fi router. I have plugged that into my test lab network here so that we will be able to give this device internet. And I've also factory reset it with a little factory reset button there where you push like a paperclip in it. And that is so I don't have to censor anything that shows up in the shell anymore. That just makes things easier for me. But other than that, this is all the same setup. We are powering it with a bench power supply because I did not have the power supply for this device. So with that, we are going to go look at our computer over here and navigate to our nifty root shell that we have set up on the device. So yeah, just a reminder, we get dropped this shell over this UART cable that we have connected up to those UART pins on the PCB, and it drops us into a full root shell. We did not have to brute force a root password hash, anything like that. It just dropped us in here. You don't usually get this lucky, but today we are. So now what we want to do is we want to extract some of the firmware. So last time I kind of showed like running the mount command, and we can see here by running this mount command that there are a lot of different ways some of these file systems will show up, especially the root file system on a device like this. But we can see here that there are actually these dev nodes on the Linux system that say, you know, dev, mtd, block, and then a number. And so this is actually going to be super helpful for us. And so what we're going to do is we're going to try to extract the different flash partitions using these mtd block device nodes. And so what we can look at is we can actually say ls mtd block star, and there we can see that we have all of those partitions on the flash chip labeled as mtd block 0 through 19, it looks like. And so those are going to be all the different, partitions that are available on this flash chip. So now we want to extract that off of the device. And so there's a few different ways that we can do this. So if we were thinking of this like any other Linux system that we wanted to pull data off of, right? Let's say you just had a Linux laptop sitting in front of you. Well, how could you pull data off of that? Obviously, like, we can't load up a web browser into this thing, but we can use the fact that it has internet connectivity to send files over the network to our local computer here. And so that is one of the methods that we're going to explore. And the other that is available on this device, and this is really device specific, whether this is a possibility at all, is there's actually a USB port on this device, and you can mount a file system from a USB thumb drive, or in this case, just just a USB terabyte hard drive, and it will actually allow you to mount that partition, and then you can load any data you want onto it and unplug it, and then plug it into your computer. So those are the two methods we're going to explore, is over USB and network. So I think the first way we're going to look at this is via USB. So right here, I just have a typical USB hard drive. It's a terabyte, and I have formatted this with FAT32, like a FAT32 partition, and the reasoning for that is because it's very widely supported, right? There could be other partitions in Linux like ext3, ext4. On like a Linux desktop, of course, you could expect that to be supported, but on embedded devices, those kernel drivers and utilities will sometimes not be built in. So that's just something to be aware of. So on this device, so just kind of showing us at the desk really fast. So right up here is a USB 3.0 port, and I'm gonna plug that in. Actually, I wanna show you guys what happens, because this is crazy how this happens. So let's actually watch the shell when I plug this in. So I plug in my USB hard drive. Give it a second here. And it actually automatically detects that the USB is plugged in, and it mounts it. And then, this is so crazy, there's obviously some kind of file share feature that is built into this router. So it's already starting to set up the files that are on this hard drive to be shared over the network using this Wi-Fi router. So that's pretty crazy. But we're not too concerned about that. That may be a feature that we might want to do some security testing on later, but for now we just want to extract this firmware. And so we run that mount command again, and here we see a new item show up right here at the bottom of the list. We see that it's gonna scroll a bunch of stuff. Here we see this SDB1 device is mounted, and it says mounted on. That means that's the folder, the directory location where that partition is mounted. So we can actually go CD into that, and you can see my testing from before. Here, we'll delete those files. Of course, that doesn't exist. But you'll notice I did not create this folder. So it just started automatically like mounting my hard drive and creating folders there and all sorts of stuff, right? So now what we need to do is we need to copy the data from all those other partitions on the flash chip into this folder, because this folder is not mounted on the flash chip. It's mounted on our removable USB hard drive. So what we're going to do, again, we're going to show what we want to copy out. So like the first thing we want to copy out is this device node. We want to do a byte for byte copy of what's being stored here. Now, we can't just run the copy command. You'll notice it says that there's, whoops, that's not what I want to do. Right? You'll notice that like the file size is like 1, right? This is just a certain type of this is like a block device, but there is actually a bunch of data that is being backed by this block device. And so what we want to do is we want to use the DD command. Unfortunately, the DD command does not exist on this system. But what's really cool is that there are projects out there of people on GitHub who host statically compiled binaries for a whole bunch of different architectures. So what we're going to do is we're going to run uname-a, and this is going to tell us right over here that this is an ARM v7L system. And so what I'm going to do is so this is an ARM, Linux system here. That's the architecture. And that's important when we go try to find a statically compiled binary, that we find one that's compatible. So I will post this GitHub repository. I use these binaries all the time. It's a really good curated set of statically compiled ARM libraries. And the first one we're going to use today is this statically compiled DD binary. So I'm going to click on this. This is a raw file. Obviously, there's like no preview. And I'm going to right click on raw, and I'm going to say copy link. So we'll go back over here, and so when I'm dropping a file, I can't just drop it anywhere. Usually, I'm going to go throw it in temp. So our temp file system right here. Okay, it's mounted read writable, and there's no exec permission here. Sometimes you got to watch out for that. If you're dealing with a system that's a little more security conscious, obviously this one is not, because it just drops you to a root shell. But that no exec permission can sometimes be set up on a partition, which would not allow you to run any executables, even if you set the executable as being executable. So here, we don't have to deal with that. So we're going to run wget on that. It's going to tell us that. I hate these terminals. All right, so it's going to tell us that we need to do no check certificate because it's having trouble with that. Go back, copy your link. Cool, so now it says we've downloaded this DD binary. But right now the permissions aren't set correctly, so we're just going to make sure that that is marked as executable. And now we should be able to run the DD program. So now we have brought onto our system this DD utility, and we can use it to copy data to our location over here. And so for that, we are going to run. So this isn't obviously not going to meet our path. We can't just type DD. We actually have to type out this full path of this binary. And then for DD, you say the in file. So it's going to be dev mtd block 0. And then we're going to specify the out file. And for this, we'll just call it mtd block 0.bin. We just call it whatever we want. And then we're going to set the block size to be 1 meg, just because that'll allow the copy to be a little bit faster. And so we're going to run that. And then it has copied that data here, not there, right here, into our USB removable hard drive. And then what we would do is we would just repeat this process for all of these partitions. And some of them will go really fast because they'll be really small, and the other ones will take a long time. And the ones that take a long time are obviously going to be the ones you probably care about more than the other ones, right? So this is one way for us to get that data off of our IoT device, where it's kind of restricted in there, and we can get this back to our computer, right? Because the next set of videos, what we're going to do is we're going to be taking the binaries, the firmware that we extract out of the system, and actually hunt and reverse engineer those binaries, looking for vulnerabilities, looking to understand how the system works. But the first step is extracting it off. So this is taking a while, so I'm wondering if this is a larger partition here, mtd block 2. All right, so just for the sake of having this go quickly, I'm going to cancel out of this, and I'm just going to, for this video, since I know that this has got good stuff on it here, I'm going to do MTD block 18. So we'll do that one, and we're gonna let this one complete. So here, when I Control-C out of this, it told me that it had copied quite a bit of data from that MTD block 2. So we are going to allow this 18.1 to complete. But in the meantime, I'm going to... Oh, there we go. Cool. That finished. All right, so there we go. MTD block 18. And so now I'm going to... Is sync not running? Okay, I just hope that the data actually is copied over. All right, so now I'm going to remove my hard drive, and I'm going to come over to my desktop machine, and we're going to this block. I've got a bunch of these disks. Come on, it should, I think in my system it's going to show up as S. Come on, man. There we go. Okay. So let's make dir mount sudo mount dev s dc1. No, it doesn't like it. All right. Let's block. I wonder if, like, the system, like, remounted it or something like that. Or it reformatted the file system. That's what I'm wondering is going on right now. So let's see what's synchronized cache failed. Okay, let's block. Yeah, it's still not showing up. Let me try that again. Synchronized cache failed. Okay, my drive is like clearly failing somehow. That's awesome. But anyway, you get the idea. When your USB device is not failing, you can pull the data off that way. We're gonna move on to our second method. So if your USB device also craps the bed, you can fall back to doing it over the network. So that's what we are going to demonstrate right now. All right, make the device shell big again. So for this one, what we're going to do is we're going to use netcat. So netcat, or NC, is also not on this system, but have no fear. We also have a static ARM binary for the netcat program. And so right here is that binary. I'm going to copy that link. And then I'm going to go to temp like I did last time, wget. What do I have to do? Like no check certificate. There we go. All right. So, okay, we downloaded that just fine. Chmod 755. So now our netcat program is executable. I just want to do -h. There we go. So now we have netcat running, or we have that binary running just fine on the router. And so now what we're going to do is we're going to use that to extract the firmware out to our machine. And so we're going to actually run netcat on both sides. So over here in our demo2 folder, we are going to prepare the netcat listener. So what we're going to do is we're going to type netcat. We do L for listen. I just kind of do this instinctively. It's like I do a bunch of these flags. Some of them I don't even know what they mean. But 1, 2, 3, 4. So we're going to listen on port 1, 2, 3, 4, right? And so what I'm going to do then is So for starters, actually, I'll show you like the way to transfer data, and then how we're actually going to transfer the firmware, because that's going to be a little bit different. So let's just call this like test.txt. And then I'm going to listen. So it's going to wait for a connection, and then when it receives a connection, it's going to write all the data it gets sent over that TCP connection into the file test.txt. So from here, I can do this, and I can say 10.10.10.2, which is my desktop machine and my test network here, and 1, 2, 3, 4. And now I can type hello world, and now I'll Control C out of that. And now over on my computer, that data got transferred, right? Now, with a binary file, we have to be careful not to just chuck it like into standard in or standard out and stuff like that, because it can do funky things to your terminal. So what we're going to do is we're actually going to compress it, then send it over the tunnel, over the socket, and then on the other side we're going to decompress the file and write the firmware. So the full command to do that is going to be, we're going to use dd like we did before. So now we're going to actually combine these two things. So we're going to do the first part like we did. So dev mtd block 0. And we're going to also specify that block size like we did last time. But what we're not going to do is we're not going to specify the out file, because instead of having an out file, we're going to have it go over standard out to standard in of the next program in line with the pipe character. And then what we can do is we can use netcat to send that over the network. No, I forgot. First, we need to compress the file. So all we have to do is do gzip-c. That brings it from standard in. And now we just copy this part of this command right there. And then on this side, we're going to add a layer. And that's going to be gunzip. And this time we'll give the file a more meaningful name. We'll call it mtdblock.bin. And so we will run that one first. We'll run this. And then after it does this, we have to Control C out of this program. See, it'll look like they're both hanging and like they still have work to do. But after dd prints this out, that's how you know that dd is done on the device side of the transfer. And then I can hit Control C. And once I hit Control C on the device, the other side will, it will be done. And now we can go and we can, see that this file was actually transferred here. And we can confirm, actually, that the transfer was exactly correct. So this is kind of cool, a cool sanity check we can do. So here is that device node, and we can actually do an MD5 sum of that device node. It's like typing things in my console. All right, so there is the MD5 hash of that entire partition. So the cool thing that we can do is we can go do an MD5 sum of that exact bin file here, and we can see the match. So we know there was no error in the transmission, or there's no encoding issues or bytes that got messed up while we were transferring that firmware. And so now obviously we can go and we can do things like running binwalk on our firmware. Okay, so maybe there's some LZMA compressed data. We can run strings on this partition. Okay, cool. There's some like board flags, some VLAN information. This is potentially like bootloader configuration stuff. Yeah, it's talking about memory, decompressing. This could be a kernel. This could be like kernel config stuff as well. So let's go ahead and do that partition that is a little bit more interesting. This mtd block 18. So we'll just go back, change this to working in a terminal like this is is not fun. All right, I'm gonna type it over over here, and then I'll paste it. There we go, and then I have to get this side ready to be MTD block 18. So start a listener first. We'll start this. If we remember last time, it took just a little bit of time, but not too long. And we'll wait around for that file to transfer. And then we're going to get ready on the other side to run binwalk. Because I'm hoping that here binwalk will actually be able to extract some of those file systems out of there. It's interesting how we see like potentially a couple different file systems being mounted from there. Not quite sure how that works. Okay, so again, DD came back with its ending, so we Control-C on the device side. There, we can actually do our sanity check again, which is kind of cool. Oh, it's going to take longer because it basically, like, if you're doing an MD5 of that every part of that partition, it has to, if you think about it, it's going to take longer the bigger the file is because it has to read every byte of that file to compute the hash. There it is, MD5 sum, and now we're going to do it on block 18. Interesting. Okay. Don't know why that is. All right. Is the file size, does the file size look good? That's so interesting. All right. Let's run. I mean, well, no, there's no reason the MD5 sum would be wrong. I mean, maybe on this side it might be wrong if like just something was not reliable, but that's surprising. Whoa, we got a different MD5 sum on this side. Okay, I don't know what that means. Oh, okay. Why is it different? Why would that partition be different? Well, I just realized. Because this is a writable file system, right? Like this system is running and it's probably writing data as we speak into these two locations. They're writable. And so the contents are going to change, right? So how you decide to do that, how you decide to do that firmware extraction, usually I'll just pull it at a point in time and use that as my starting point for my analysis. Yeah, that's usually how that goes. But now let's bring this center stage. Okay, I'm gonna run binwalk on this thing. Okay, we have a file system, and that file system type again matches what we're seeing from the mount command on the other side, which is really great. Okay, so now we can run binwalk with the -E flag for extraction. So there it will attempt to extract that file system. Okay, yeah, it's just telling me it's gonna change some symlinks. And I believe that's because there was a security issue reported in binwalk where you could trick people with like maliciously created firmware files. Okay, so let's go look in here. It pulled out this JFS-FFS2 file system, and here we get this data extracted. And again, if this looks familiar to me, it's going to be in one of these two things. Nope. Okay, it's in this one. So there you can see those same files. So we successfully extracted that file system, and now we can perform all this analysis with all the tools, with a full suite of firmware analysis tools, reverse engineering tools. We don't have to be limited to this shell. We do have a root shell, right? But as you can see from us having to pull in static binaries, we don't have all the tools we would want to perform the analysis we need to perform in this shell on the device itself. that's why it's really nice to pull all of that data off onto our full featured Linux desktop or whatever operating system of your choice to perform our firmware analysis. So thank you for watching this video. In the next ones, we're going to actually take a look at this firmware and do some reverse engineering and maybe try to recreate some of the publicly reported vulnerabilities in this Netgear router. Thank you and have a good day.